Humans drink cow's milk because cows won a competition they never knew they had entered. Not because their milk was designed for us, it was designed for calves, and not because early humans sampled every mammal like judges at an extremely dangerous beverage festival. Most candidates were eliminated immediately. Some were too small, some produced almost nothing, some lived in places where farming was nearly impossible, and some reacted to attempted milking by making sure the experiment had no second trial. Cows happened to combine several useful traits better than almost any alternative. They were large, social, manageable, adaptable, and capable of producing substantial amounts of milk. Even when they were not being milked, they pulled plows, fertilized fields, supplied hides and meat, and converted grass humans could not digest into food humans could. Then history gave them selective breeding, refrigeration, railways, pasteurization, colonial expansion, government subsidies, and advertisements featuring children with suspiciously perfect bones. The result is the modern dairy aisle. Today, cattle produce more milk worldwide than every other dairy animal combined. Buffaloes provide most of the remainder, while goats, sheep, camels, yaks, mares, and other animals occupy much smaller shares. But that global total hides enormous regional differences. Buffalo milk is central to much of South Asia. Sheep and goat milk shaped cuisines across the Mediterranean and Middle East. Camel milk remains essential in dry parts of Africa and Asia. Central Asian pastoralists traditionally ferment mare's milk. Highland communities use yak milk. And for most of history, many East and Southeast Asian societies consumed little fresh animal milk at all. Humanity never gathered around a prehistoric table and officially chose the cow. The cow became the default gradually. And to understand how, we first have to confront the strangest part of the habit. Adults are drinking baby food from another species. Milk evolved as the defining mammalian system for feeding offspring. It contains water, fats, proteins, sugars, minerals, immune components, and other substances tailored by evolution to support the young of the animal producing it. Seal milk is extraordinarily fatty because seal pups need insulation quickly. Rabbit milk is concentrated because mothers nurse for short periods. Human milk supports a slowly developing infant with an unusually expensive brain. Cow's milk helps a calf become very large, very fast. None of it evolved for coffee. For nearly all mammals, drinking milk ends at weaning. The young animal begins eating its adult diet, the mother stops lactating, and the relationship concludes without anyone inventing yogurt. Early humans followed the same biological pattern. Human babies produce lactase, an enzyme in the small intestine that breaks lactose into simpler sugars the body can absorb. After childhood, lactase production usually declines. That remains the ancestral condition and is still common across most of the world. When someone with low lactase activity drinks more lactose than they can handle, the undigested sugar reaches the colon. Bacteria immediately recognize a business opportunity. They ferment it, producing gas and drawing in water, which may cause bloating, cramps, flatulence, or diarrhea. The response varies. Many people tolerate small servings. Yogurt and aged cheese often contain less lactose. Lactose intolerance is not a simple switch. But the larger point remains. Adults who struggle with fresh milk are not biologically defective. Adults who can digest large quantities easily possess a relatively recent evolutionary adaptation. So why did our ancestors start dairying before most of them could comfortably drink the product? Because they did not begin with glasses of fresh milk. Cattle, sheep, and goats were domesticated in Southwest Asia around 10 or 11,000 years ago. Early herders valued them for meat, hides, wealth, and a living food supply. A herd was meat that had not expired yet. But slaughtering an animal creates one unfortunate limitation. It only works once. Milk offered repeated returns. A female could provide food for weeks or months while remaining alive, reproducing again and adding offspring to the herd. The same animal might later supply traction, manure, hide, and meat. A goat was no longer merely future, dinner. It was a subscription. Archaeologists have found evidence of early dairying in the fat residues preserved inside ancient pottery. Unglazed clay absorbs tiny amounts of whatever was cooked or stored in it. Thousands of years later, the chemical patterns of those fats can sometimes reveal whether a vessel held dairy products rather than meat fats. These residues show that Neolithic communities processed milk in parts of Anatolia and southeastern Europe. Dairying then spread through Europe with farming, although it developed differently across regions. Yet genetic evidence suggests that adult lactase persistence was still rare. Ancient people solved that apparent contradiction with technology. They let microbes eat first. During fermentation, bacteria convert some lactose into lactic acid. Sour milk and yogurt can therefore be easier to digest. Cheesemaking separates solid curds from watery whey, carrying much of the lactose away. Aging reduces it further. Butter concentrates milk fat and contains little lactose. These processes also extended storage. Fresh milk spoils rapidly, but cheese, butter, and fermented milk can survive longer and travel farther. The first successful dairy cultures may not have depended on adults enthusiastically drinking fresh milk. They may have depended on turning milk into something else before breakfast became a gastrointestinal emergency. Culture changed first. Biology followed. In several populations that relied heavily on livestock, genetic mutations allowed lactase production to continue into adulthood. This trait is called lactase persistence. It evolved more than once. Different variants associated with adult milk digestion appeared in Europe, East Africa, the Middle East, and possibly other regions. Separate populations encountered similar pressures and evolved similar abilities through different mutations. Humans created dairy environments, and those environments changed which human genes were useful. This is gene culture coevolution in unusually visible form. Why was lactase persistence so advantageous in some places? Fresh milk delivers water, energy, fat, protein, calcium, and other nutrients without killing the producing animal. Mobile herders could turn vegetation spread across land unsuitable for crops into a dependable food supply. During famine, drought, or crop failure, milk may have provided a crucial reserve. People who digested it efficiently could absorb more nutrition and avoid the fluid loss caused by severe intestinal symptoms. At high latitudes, milk's calcium and its relationship with vitamin D metabolism may also have mattered where sunlight was limited. The complete explanation is still debated. No single theory fits every dairying population. Some societies developed strong milk traditions without high lactase persistence rates because they fermented or processed dairy. Others consumed little milk despite keeping livestock. Ecology, disease, mobility, food preparation, and cultural preference altered the pressure everywhere. Milk did not transform all humans in the same way, but none of this yet explains why the animal was so often a cow. Early farmers milked sheep and goats too, and both remain better choices in many environments. Goats browse shrubs and rough vegetation. They tolerate dry, rocky landscapes, reproduce fairly quickly, and require less land and feed than cattle. Sheep provide wool, meat, and milk. A family that cannot support a cow may still support several smaller animals. A cow is an enormous agricultural commitment with opinions. Its size, however, is also its advantage. A large lactating animal can produce far more milk per individual. Modern dairy cows have been selectively bred to generate quantities their wild ancestors never approached. A high-producing cow can supply dozens of liters in a day during peak lactation. A goat provides much less. Supplying a city with goat milk would require many more animals, more separate milkings, and a government department devoted entirely to goat administration. Cattle also convert food that humans cannot use directly. Their rumen contains microorganisms that break down cellulose from grass, hay, crop residues, and other fibrous plants. The cow then transforms microbial products into body tissue and milk. Other ruminants perform the same basic miracle. But cattle combine large output with wide adaptability. Taurine breeds thrive in many cooler regions. Zebu cattle tolerate heat and parasites more effectively. Local breeds and crossbreeds extend cattle into humid, dry, temperate, and tropical farming systems. They also integrated remarkably well with agriculture. Oxen pulled plows, carts, and water lifting equipment. Manure fertilized fields, fueled fires, and sometimes became building material. Cattle provided leather, horn, bone, meat, savings, ceremonial value, and social status. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. A cow was not merely a milk machine. It was a tractor, fertilizer factory, bank account, and large mobile object that somehow always stood in the least convenient location. This multi-purpose value spread cattle even where dairy was not the main goal. Once farmers already kept cows for labor or meat, milking became an additional benefit. Once milk became valuable, they could breed animals that produced more of it. But milking required another negotiation. Milk belongs biologically to the offspring. A cow does not lactate because a human owns a bucket. She must become pregnant, give birth, and experience hormonal milk let down. Traditional herders often allowed the calf to begin nursing or remain nearby. Its touch, smell, and sound could stimulate oxytocin, causing milk to flow. The human then collected a share. Successful dairying required careful knowledge. When to breed, how often to milk, how much the calf needed, what the mother should eat, and how to prevent injury or infection. Domesticated cattle were suitable partly because people could train them to tolerate repeated handling. Over generations, humans selected calmer animals with useful udders, accessible teats, reliable letdown, longer lactation, and higher output. Animals violently committed to refusing the procedure were less likely to establish celebrated dairy bloodlines. Domestic cattle descend from aurochs, giant wild bovines that once ranged across Europe, Asia, and North Africa. Aurochs were powerful, fast, and far less cooperative than modern dairy breeds. Trying to milk one would have been less an agricultural experiment than a creative method of leaving the archaeological record. Domestication changed that relationship. Later selective breeding changed it even more. By the 19th and 20th centuries, herd records allowed breeders to identify productive families. Veterinary care improved survival. Artificial insemination spread desirable genetics. Modern evaluations compared milk yield, fat, protein, udder health, fertility, and body structure across enormous populations. The Holstein did not emerge because someone asked an ordinary cow to believe in herself. It is a highly specialized biological product of human selection. Still, cattle did not win everywhere. Water buffaloes are exceptional dairy animals in hot, wet regions. Their milk usually contains more fat and total solids than cow's milk, making it valuable for ghee, sweets, butter, and cheese. India and Pakistan produce enormous quantities, and many consumers prefer it. But buffalo populations remained concentrated mostly in Asia. They were less suited to the cold regions that later built Europe and North America's industrial dairy systems. Geography placed cows inside the countries that would construct influential global processing networks. Goat and sheep milk followed different commercial paths, particularly through cheeses such as feta, pecorino, roquefort, and chèvre. Their flavors can be more distinctive, but taste is learned. Someone raised on goat milk may find cow's milk strangely empty. Mass markets reward familiarity. Once cow's milk became the standard, every other milk was judged against it. Milk meant cow. Goat milk needed an introduction. Camels dominate where cattle may struggle. They travel long distances, tolerate heat and water scarcity, and continue producing in harsh conditions. Camel milk is culturally and economically important across dry regions of Africa and Asia. But camels mature and reproduce slowly, have long pregnancies, and are harder to integrate into high-speed mechanical systems. Specialized dairy cows generally yield more. A camel is an outstanding dairy animal when the landscape is actively trying to kill a cow. It is less competitive on an intensive farm beside a refrigerated processing plant. Fermented mare's milk has a long history in Central Asia, while yaks, reindeer, and donkeys serve particular environments, but horses need frequent milking and were already valuable for transport and labor. The horse had another career. Cattle occupied the broad middle, not ideal everywhere, useful almost everywhere. Their next major advantage appeared as towns grew into cities. Fresh milk is an excellent microbial habitat. It contains water and nutrients, arrives warm, and begins spoiling quickly unless cooled or processed. For most of history, people consumed it near the animal or converted it into butter, yogurt, cheese, and other preserved foods. Urbanization separated consumers from livestock. Cities needed huge quantities collected reliably, transported quickly, tested for contamination, and kept cold. Cows were well suited to centralized supply because each animal produced a large volume. Farms could specialize, combine their milk, and deliver it to processors. Then, infrastructure reinforced the species already in front. Railways and trucks expanded delivery distances, pasteurization reduced dangerous pathogens through controlled heating, refrigeration slowed spoilage. Cream separators processed milk efficiently. Glass bottles and later cartons standardized sale. Condensed milk, evaporated milk, powder, and ultra-high temperature treatment allowed dairy to travel far beyond the farm. Milking machines were designed around cattle udders. Feed industries optimized cattle diets. Veterinary systems focused on dairy herds. Factories were calibrated for cow's milk. Breeding produced cows better suited to those factories, making investment in cattle even more profitable. This is path dependence. Something does not need to be the only good option to dominate. It gains an early advantage, attracts infrastructure, shapes consumer habits, and makes alternatives increasingly expensive to adopt. The QWERTY keyboard understands. So does the cow. European colonial expansion carried cattle and dairy institutions across much of the world. Colonists introduced or expanded European breeds in the Americas, Australia, New Zealand, Southern Africa, and parts of Asia. Land was reorganized for pasture and feed crops. Indigenous food systems were displaced, suppressed, or altered. The spread of cow's milk was therefore not just the peaceful diffusion of a useful beverage. It often traveled with conquest, settlement, and new ideas about which foods counted as civilized or healthy. By the 19th and 20th centuries, European and North American nutrition science increasingly presented cow's milk as an important food, especially for children. Milk offered protein, fat, calcium, and vitamins in a compact form. In crowded cities, pasteurized milk could genuinely improve nutrition when safer, consistent supplies replaced contaminated raw products. But nutritional value was only part of the story. Governments supported dairy farmers through research, price controls, subsidies, purchasing programs, and school distribution. Militaries bought processed dairy. Public campaigns linked milk with sanitation, growth, strength, and national health. Some claims were reasonable. Others arrived with the reassuring confidence of an industry standing beside a massive advertising budget. School cartons taught generations that drinking cow's milk every day was simply what healthy children did. Agricultural policies encouraged production, while surpluses became butter, cheese, or powder. Industry also learned to dismantle milk into profitable parts. Fat became cream and butter. Casein became cheese or industrial ingredients. Whey, once considered an inconvenient byproduct, entered baked goods, infant formula, protein powders, and sports supplements. The cow no longer produced a single drink. It produced an ingredient system. Milk powder helped globalize that system. Removing water reduced weight and slowed spoilage. Powder could travel without a complete cold chain, be reconstituted later, or disappear invisibly into processed foods. Cow dairy entered diets in places where drinking fresh milk had never been traditional. Sometimes this provided accessible nutrition. Sometimes it imposed a foreign dietary habit while pretending to reveal a universal human need. Cow's milk still never became equally normal everywhere. Lactase persistence remains relatively uncommon across much of East and Southeast Asia and among many indigenous American populations, though rates vary greatly within every region. China, Japan, and many Southeast Asian societies developed sophisticated cuisines without building daily meals around fresh dairy. Protein and minerals came from soybeans, fish, legumes, seeds, vegetables, grains, and other foods. They had not overlooked a cow-shaped hole in civilization. They had created different food systems. Meanwhile, several African pastoral populations made milk central to daily life and evolved high lactase persistence frequencies using genetic variants different from the best-known European one. Milk drinking is not simply European. What became disproportionately European was the industrial system that turned cow's milk into a standardized global commodity. Even within Europe, people often consumed dairy as cheese, butter, or fermented milk rather than drinking it fresh. The image of timeless villagers pouring tall glasses at breakfast is partly modern. Preservation was historically the greater concern. Cheese was milk refusing to die on schedule. Cow's milk also remained dominant because it is technologically cooperative. Its fats and proteins can be separated or transformed into cream, butter, cheese, yogurt, condensed milk, and powder. Other animal milks can do many of these things, sometimes better for a specific product. But centuries of accumulated recipes, equipment, regulations, testing standards, and supply chains make cow's milk unusually convenient at industrial scale. A company producing millions of identical cheese slices needs predictable chemistry, standardized herds, cultures, machinery, testing, and laws. Cow dairy already owns that ecosystem. Its nutritional reputation continues to protect the system. Cow's milk provides complete protein and is naturally rich in calcium, phosphorus, vitamin B12, and other nutrients. Many countries fortify it with vitamin D or vitamin A. For people who tolerate and enjoy it, it can be a convenient part of a healthy diet. Convenient does not mean essential. Humans do not biologically require cow's milk specifically. Its nutrients can come from other foods. A well-planned diet can be healthy with dairy, without dairy, or with dairy used mainly as cheese doing its best to dominate the meal. Milk is neither a perfect food required by every human, nor a mysterious white poison capable of destroying civilization. Context has once again ruined an exciting argument. Lactose intolerance must also be separated from milk allergy. Intolerance results from difficulty digesting lactose and usually causes gastrointestinal symptoms. Cow's milk allergy is an immune response to proteins and can be severe. One involves insufficient enzyme activity, the other involves the immune system declaring war. Modern dairy's environmental and ethical costs now challenge the cow's position. Dairy systems range from small pasture farms to immense intensive operations. Animal welfare depends on breeding, housing, healthcare, milking, calf separation, transport, and how animals are treated throughout their lives. Cattle also produce methane during digestion. Feed cultivation, manure, land use, water, energy, cooling, and transport create additional environmental effects. The cow's ability to turn grass into milk remains remarkable. The atmosphere still receives an invoice. Plant-based drinks have expanded, partly in response. Soy, oat, almond, coconut, rice, and other products compete for the same role in cereal, coffee, cooking, and nutrition. Their nutritional profiles are not identical. Fortified soy can provide comparable protein, while many alternatives contain much less. Sugar, calcium, vitamins, and energy vary widely. Some cartons are carefully formulated foods. Others are water, carbohydrates, and excellent typography. That difference matters particularly for infants and young children. Yet, these alternatives reveal that milk has become more than a biological substance. Biologically, milk is produced by mammary glands. Culturally, milk is a pale liquid assigned a job. It goes into coffee. It's often cereal. It enriches sauces. It provides certain nutrients. Once the function became more important than the animal, plants could compete for the category. Future technologies may push the separation even further. Precision fermentation can use microorganisms to produce specific dairy proteins without raising a cow. New products may eventually reproduce more of milk's taste and behavior. Climate pressure, price, politics, welfare concerns, and consumer habits will determine how far they spread. But replacing cow's milk means replacing more than a liquid. It means replacing farms, factories, laws, subsidies, recipes, childhood memories, and a century of nutritional messaging. It also means replacing cheese, at which point many otherwise adaptable people immediately suspend negotiations. So why do humans mostly drink cow's milk? Because cows were complete agricultural systems before they became specialized dairy machines. They converted inedible plants into food. They produced more milk per animal than smaller livestock. They supplied traction, manure, meat, hides, wealth, and social value. Different cattle adapted to a broad range of climates. Their social behavior and temperament allowed repeated handling. Human breeding then magnified their yield and changed their bodies for milking. When cities expanded, cows suited centralized production. When industrial equipment arrived, it was built around cows. When European powers expanded, they spread cattle and their food habits. When governments promoted nutrition, they placed cow's milk in schools and public policy. When factories needed standardized ingredients, cattle already supplied the volume and chemistry. Then, familiarity completed the victory. Once cow's milk became simply milk, every competitor became unusual. But the deeper story reverses the obvious assumption. Humans did not choose cow's milk because our bodies were naturally designed to drink it. Most adult bodies originally were not. First, humans changed milk through fermentation, cheese-making, and storage. Then dairy culture changed human genetics in some populations. Humans transformed cattle through selective breeding. Finally, industry transformed a regional relationship into a global default. The glass in the refrigerator is therefore not a simple product of nature. It is the outcome of 10,000 years of negotiation among calves, microbes, human genes, climate, farming, migration, conquest, technology, economics, and taste. Remove any of those forces and breakfast might look very different. Perhaps goat milk would dominate, perhaps fermented buffalo milk, perhaps most adults would never consider drinking animal milk directly. Perhaps cereal would remain dry, forcing humanity to confront what cereal actually is. Cows won because they occupied an unusually useful position between the tiny and the unmanageable, the specialized and the fragile. They were large, productive, adaptable, multi-purpose, and already widespread when modern dairy systems began expanding. The cow did not produce the only milk humans could drink. It produced the milk history was best prepared to multiply. And once humans built an entire world around that animal, the strange habit of drinking another species' infant food stopped looking strange. It became so ordinary that every alternative required a label. Goat milk, buffalo milk, camel milk, soy milk, oat milk. But the cow's version walks into the refrigerator, takes the largest shelf, and simply calls itself milk.